So today is December 1st, and since it's the 1st of December, I want to talk about something that there's only one of in the standard model of particle physics. Now, all the particles sort of come in pairs. We have the up quark and the down quark, we have the electron and the electron neutrino, we have the W plus and the W minus, and in all these different particles there's only one that doesn't really get paired up with the rest, and that is of course the Higgs boson. Now, if you've been paying attention to news in particle physics this year, you'll have seen the Discovery seminar on July 4th, and then you'll have heard the updates in November from HCP. It pretty much looks like we've got a Higgs boson, which is fantastic. This is the final particle in the standard model that needs to be confirmed in order to complete our picture. And apart from the mixing of neutrinos, the standard model gives us a very accurate view of the universe. Now, one of the interesting things about the Higgs boson is that its mass is not predicted, but once you know its mass, if it's a standard model Higgs, then you know everything else about it. And so what this means is the discovery of the Higgs boson at around 125 GeV has completed the standard model. That means that, ignoring neutrinos, which I'll discuss in another video, we pretty much know everything there is to know about particles now. Well, that's not quite true. What we're hoping for is that there's something else to discover out there, something else very exciting that will tell us something new about the universe. Because if there isn't, then the only thing that we'll have found is the mass of the Higgs boson. Well, I should probably talk a bit more about why the Higgs boson is exciting. I mean, the interpretation that I just gave was a bit of a downer, really, that there's nothing new out there beyond the Higgs boson. Now, the reason it's exciting is, of course, that it's predicted nearly 50 years ago, and its prediction by all these fantastic scientists, you know, Higgs, Engler, Brout, Kibble, and so on, it was a stroke of genius for them. They took a look at the standard model and realised that there was this problem that had to be resolved. If we had heavy gauge bosons, we must also have a scalar field to take all this into account. And without any evidence, they put forward these models, and they were internally consistent, and they predicted this standard model Higgs boson. Now, what makes the Higgs boson discovery so exciting is that it took so long to discover. You take a look at the other particles and you have things like the W and the Z bosons, and the nice thing about the W and Z bosons is that they decay directly to leptons. So all you need to do really is put together a particle accelerator, put some detectors on it, and look for high energy leptons, and that's what happened in the early 1980s, and that got the Nobel Prize for the discovery of the W and the Z. Then you take a look at things like the top quark, another very heavy particle, and that also decays with leptons in the final state, very, very high energy leptons. And so that signature is a bit more tricky to find, but that was also found in the tevatron in the 1990s. Now, the Higgs boson took until 2012 to discover because its final states are really quite difficult to find. You're looking for things like B quarks and tau leptons. They have all kinds of problems with them, they're very messy. Or you can look for things like the gamma-gamma final state, which has a huge background, or you can look for things like the 4 leptons final state, which are very, very clean, but also very rare. So I think what makes the Higgs boson discovery very, very exciting is that it's taken the state-of-the-art technology of the 21st century, it's taken the planning of decades of work, it's taken all kinds of measurements from other experiments, and it's taken the best models and theories we have of the universe and combined all of that into a single discovery, and with this discovery we complete the standard model. Still, I'm hoping there's something else out there to make things even more exciting. So anyway, that's all about December 1st, it's all about the Higgs boson, why it's exciting and why it has made 2012 one of the best years we've seen for a very long time for particle physics. It has been a phenomenal year, and I'm really sad to see 2012 come to an end.